Everywhere?
Yes,
Yes,
ma'am.
ma'am.
Hello, ma'am.
Yes,
Yes, ma'am.
yes, yes, yes.
Good morning, ma'am.
Yes, very good morning, very good morning. Shall we start?
Yes, ma'am.
Yes. So, what were we discussing in the previous session? The last concept that we were discussing, can anybody tell me? The last concept that
Fazan's
we discussed?
rule.
Very good. Fazan's
Ionization
rule.
Fazan's
enthalpy.
rule.
Yes, Fazan's rule. Now, I just want to know whether you remember that Fazan's rule or not. I'll give one question. Let's say we have two compound, KCl and CuCl, copper chloride and potassium chloride. Now you tell me which will have high melting point. Which will have high melting point.
Copper.
Think and tell me.
Potassium chloride.
You don't have potassium chloride and copper
Copper
chloride.
chloride. Copper chloride.
Copper chloride.
Yes, ma'am.
Okay. Others? Chikkodi, can I get answer from you? Chikkodi students?
Ma'am, from RLS, copper chloride.
Okay, okay. Copper chloride. Raiba Keli, what's your answer?
ಕಾಪರ್ ಕ್ಲೋರೈಡ್ ಮಿಸ್.
Copper chloride.
ಮೇಡಮ್ ಒಂದು ಎರಡು ನಿಮಿಷ ರೀ.
Nippani students?
ತಗೋರಿ ಮೈಕ್ ತಗೋರಿ ಎಲ್ಲ ಒಂದ್ ಕಡೆ ಕುತ್ಕೋರಿ ಹೇಳವ್ರಿ ಸರ್ ಯಾರ್ಯಾರು ಹೇಳವ್ರಿ ಒಂದ್ ಕಡೆ
There's a disturbance from one mic. I don't know from where. Please use your mic only to answer. Okay. If I were to give you a question like this, which will have high ionic character? What would be your answer? High ionic character.
ಪೊಟ್ಯಾಷಿಯಂ ಕ್ಲೋರೈಡ್.
Copper chloride.
Potassium chloride from which class?
From for melting point from St. Joseph potassium chloride.
For melting point, potassium chloride from St. Joseph.
Yes.
Can you tell me why potassium chloride should have high melting point? Try. What are you applying? As I said, this is based on Fazan's rule only. That's why I asked you ionic character part also. Right? How can you say that potassium chloride will have high melting point? No.
Fazan's rule.
Huh?
By Fazan's rule.
By Fazan's rule. Wow, wow, what an answer. How are you applying Fazan's rule? Tell me that. Okay, you tell me, Saint Joseph student, you tell me which among these two will have high ionic character. What do you think? High ionic character.
Potassium chloride.
Copper
Potassium
chloride.
chloride. Copper chloride from Saint Joseph. So according to you, copper chloride will have high ionic character. So if copper chloride will have high ionic character, potassium chloride should have least ionic character and more covalent character. Then your answer would be wrong. Look, if a compound should show high melting point, it should have high ionic character. Okay, remember this point. Yesterday we discussed only about how to find out which is more ionic, which is more covalent. I want you to note down this as well. More ionic character means more melting point, high melting point. Now, how do we find out ionic character? We find out ionic character using covalent character, right? Covalent character. Now, we have same anion in both the cases, but the difference is between cation, potassium plus and copper plus we have. Now, based on cation, can you tell me which will have high covalent character based on cation? We cannot
Copper.
compare anion.
Copper.
Yes? Copper.
Copper.
Why do you say it is copper? You're correct. You're correct. Copper
High covalent
chloride.
character, low ionic character.
I understood. Why copper plus will have high covalent character?
High charge.
Yeast size.
Least size is one way of thinking. Another way, compared to potassium, the size
Charge.
is smaller. Another way. Then
Large
I
charge, ma'am.
charge is same potassium plus and copper plus, same charge. There is one more point, the last point which I had mentioned in the last class. Huh? Pseudo noble gas configuration. None of you are able to recollect that. Pseudo noble gas configuration. Copper plus this has pseudo noble gas configuration. I told you if you come across any metal which has pseudo noble gas configuration, that will have high covalent character. High covalent character. What is pseudo noble gas configuration? What is copper? 29 atomic number. So it is 3D10 4s1. Argon 18. So Cu plus means I'll remove this electron, outermost electron. I end up having argon 18 and 3D10. Now this is called pseudo noble gas configuration. Noble gas, along with that we have completely filled d orbital. Completely filled d orbital. This is pseudo noble gas configuration. If you have a metal having this kind of configuration, that will for sure have high covalent character. High covalent character means least ionic character. So that means copper chloride will have least ionic character and potassium chloride will have high ionic character. High ionic character means high melting point. High melting point. Okay, this is how you have to find out this high melting point wala question. If you get, remember you have to find out, you have to apply Fazan's rule. Okay, find covalent character, you'll get the ionic character value, then you can find out this. Okay, so now we'll move on to other concepts of this D and F block elements. So far we have studied two properties of D and F. I mean, we are actually studying about D block elements, transition elements. Two properties we have studied. Which are those properties, important properties? First of all, we studied about electronic configuration. Next, we studied about magnetic property. And we studied how to find out magnetic moment, that is root of n into n plus 2, where n is number of unpaired electron. And we studied one more thing. If it has unpaired electron, it will be paramagnetic. If there is no unpaired electron, it is
Diamagnetic.
diamagnetic. So we studied this as well. And one more property is color.
Colored ions.
Ion.
Yes, color due to DD transition, and to show color, it should have what? Unpaired
Paired electrons.
electron. And I had given you one exception, I mean I think two exception of the compounds which are colored even without unpaired electron. Which were those compounds? Can you tell me? Two
Mn7
compounds.
plus.
Huh?
Mn7 plus.
Yes, Mn7 plus, that means potassium paramanganate, KMnO4, which was purple in color, even without unpaired electron, and also potassium dichromate, K2Cr2O7. Remember, these are the compounds which are colored even without unpaired electron. Okay, so along with this, I remember discussing another point or another property, that is ionization energy.
Enthalpy.
Yesterday's class was devoted to this, right? Ionization energy. Yes. In today's class, we shall discuss about oxidation state of transition metals. Okay, one important property of this transition metal is that they show multiple oxidation state. Multiple oxidation state. Not only one. You take sodium. Sodium generally show +1 charge, right? You take magnesium. Magnesium generally always it will show +2 charge. Now you come to D block elements, you will see these elements show different number of charges. We'll write D block elements. Can you tell me? Scandium, titanium, vanadium, chromium.
Chromium,
Yes,
manganese,
manganese,
iron,
iron,
cobalt,
cobalt,
nickel,
nickel,
copper,
copper.
Copper, zinc.
I'll write zinc over here. Okay. Yes. Now these are our transition elements. I'm going to write their multiple oxidation state. Okay. Now look, these are our transition elements, and these are the oxidation states that are shown by these transition elements. Now what do you mean by oxidation state? Oxidation state is the charge acquired by these elements or metal atoms by losing electron, right? If I'm saying Mn2 plus means manganese has lost 2 electron. Iron 2 plus means it has lost 2 electron, okay? So these are the charge acquired by these elements by losing electron. Now, the common kind of question that you would get in this oxidation state is which of the transition metal will show maximum oxidation state? Which is that?
Manganese.
Mn.
Manganese, right? Manganese. Observe manganese. It can show 2, 3, 4, 5, 6, 7. Up to 7 it can show. Very, very important point. Okay? Manganese show maximum oxidation state. And there will be one more question based on this, which will not show generally, which will not show multiple oxidation state. Multiple means more than one. Which
Scandium.
is that?
Scandium.
Scandium
And
Zinc.
zinc. Okay, scandium and zinc. Zinc is always, it is going to show +2. Always remember, it is only going to show +2. Scandium also 95%, 98% cases it always show +3, but rarely it can show, very rarely it can show +2. Okay, so if they ask you and if they give you 2 ions in an option, you can go for scandium and zinc. Okay, now one more thing I want you to note down. These things you will get in your textbook, NCERT textbook. One thing which they don't mention in NCERT textbook, if they ask you which of the D block element will show high or maximum oxidation state, then you can go for osmium if it is mentioned in the option. These whatever elements I have written, these elements, they belong to 3D transition series. They belong to 3D transition series. Okay, we have 4D, 5D transition series also. Now totally if they ask you about D block elements and if they have given osmium as an option, you have to go for osmium. If they mention only in 3D series, you can go for manganese. Okay,
Manganese.
remember osmium can show up to +8 oxidation state. Remember that. Okay, remember that. Now one more point, I don't know whether you know this or not. I want answer from students for whom this chapter has been completed. Now if you observe, here I have given this, I have marked these oxidation, right? Round off madidini, these oxidation state. These are common oxidation state. That means manganese can show all these oxidation state, but commonly they will show +2 and +7. Okay? Now if you see in copper can show, I'll write here, copper can show +2 and +1. But the most common oxidation state is +2. Generally it shows +2 and +2 is more stable than +1. Why is that? Can anybody tell me?
Enthalpy of delta hydro.
Huh?
Enthalpy of delta hydro.
Hydration enthalpy.
Delta
Hydro.
hydration energy. Will that be high or low?
More.
More. What do you mean? Can I know who is answering? Is it from Raiba?
Yes.
Yes. What do you mean by hydration energy? Do you know exactly what is hydration energy? Very good. Your answer is correct. Hydration energy. That is correct, whatever you have said. But what is hydration energy? Why the ion is stable if it has more hydration energy? Any idea? Yes or no? I will explain if
No,
you
no.
don't know. No? Okay, fine. Whatever he answered, he is correct with that. Copper 2 plus will have more hydration energy than copper plus 1. Let us understand this. This is very, very, very important point, because they will frame question based on this, why not that, like that. Okay. Now, when we see copper in 2 oxidation state, copper, let us take copper 29, argon 18, 3d10, 4s1.
Four, one.
Right. Let us convert this to copper plus 1. What do we get? Argon 18. Remove this one electron, we'll get 3d10.
3d10.
Okay.
3d10.
Now I'll convert this to copper 2 plus. If I have to convert that to copper 2 plus, I'll remove this one electron as well as one electron from 3d10. I'll get
3d9.
3d9.
9.
Right. So generally, when we use so far whatever knowledge we have acquired from this chapter, we would say copper plus 1 to be more stable. Why we would say copper plus 1 to be more stable?
Fully filled
Refilled
Yes,
electron.
yes, right. Generally, if you see the electronic configuration, you would say 3d10 having fully filled orbital should be more stable. That means copper plus 1 should be more stable than copper 2 plus. But that is not the case. Copper 2 plus is more stable than the copper plus 1. Now, why is that? Now, we have to find out the stability in aqueous medium. In aqueous medium. Now, what do I mean by that? Look, I have taken copper 2 plus and copper plus 1 in aqueous medium. That means in water. Okay. Now, when I add these salts, copper plus 1 salts or copper 2 plus salts in aqueous medium, in water, what will happen? These water molecules will get attracted towards these ions. Okay, whether it is copper 2 plus or copper plus 1, it will get attracted towards this ion. Why is it getting attracted? Look, in water we have negative, slightly negative charge on oxygen, slightly positive charge on hydrogen. These negatively charged oxygen will get attracted towards the positively charged copper ions. Okay. Now, the attraction is very strong when the charge on cation is high. If charge on cation increases, attraction power increases. Attraction power increases. Okay. Now, let's say we have a copper 2 plus ion and I have dissolved this copper 2 plus ion in water. Okay. Now, water molecules are getting attracted towards this copper 2 plus ion. When these molecules are attracting towards copper 2 plus ion, they will release some energy. They will release energy. That energy released while these water molecules are getting attracted towards copper 2 plus ion, that is called hydration energy. Hydration energy. What is hydration energy? Energy released when water gets attracted towards cation. Cation. Okay? Cation. Now, if the attraction is very strong, the amount of energy released will also be very high. Okay? More attraction, more energy released, which is hydration energy, delta H hydration. Then more the stability of ion. Okay. If water molecules are strongly attracted by the cation, it will hold those cations very strongly. Alva? In that case, that cation is very stable in aqueous medium. It is very stable in aqueous medium. Okay? You have to remember one thing, as charge increases, the hydration energy increases. As hydration energy increases, the stability also increases. The stability also increases. Okay, this point you have to remember. You have to remember. Okay, why? Because of the hydration energy. For the very same reason, if you have, let's say, if you have copper plus 1 salt, generally when you add copper plus 1 salt in aqueous medium, it will get converted into copper 2 plus and copper. Okay, this reaction is also very important. Can you please note down this point and this point? Everybody. And can anybody, along with this, can anybody tell me what kind of reaction is this? Can you name this kind of reaction?
Complex reaction.
This one
Disproportionation
is,
reaction.
Complex reaction.
Disproportionation reaction.
disproportionation. Very good, very good. This is called disproportionation reaction. Remember this also. What is disproportionation reaction, by the way?
It undergoes both oxidation
Correct?
and reduction.
Yes, yes. A single species, it is undergoing both oxidation and reduction. Look, plus 1 is converting into, you can take 2Cu plus, plus 1 is converting into plus 2. What kind of reaction this is? Reduction or oxidation?
Oxidation.
Oxidation. Very good, very good, very good. So loss of electron, plus 1 in the plus 2 andre, you have removed one more electron, alva. Then only you will get plus 2. This is oxidation. And plus 1 to, this is 0. There is no charge under it is 0. Plus 1 to 0 is reduction. So if a single species, if it is undergoing both oxidation and reduction, then you would call it as disproportionation reaction. Now when I have this copper plus 1 ion in aqueous medium, it will convert into these two. Why this is breaking into copper 2 plus? Because copper 2 plus is more stable in water than copper plus 1. This is the reason. Okay, they can frame question in this way: why this disproportionation reaction is happening, or between these two which is stable. They can frame question in any way, but this is very, very, very important. This question has been asked in all kind of competitive examination repeatedly. That's why I explained the entire concept so that you remember this one. Okay, everybody, you remember this? You will remember this for next class. I'm going to ask this again.
Yes,
Pakka, you
ma'am.
understood everything about hydration energy? Yes, yes. Very good. Now,
Miss.
one more thing I'll mention, and we'll discuss question now after this. Now, here, where is that? Oxidation state. Now look, I have written oxidation state of a 3D transition metal. Now 4D and 5D transition metal will also follow similar kind of oxidation state. There will be some variation, but you don't have to worry about that. Now I have chromium which can show multiple oxidation state, and it can take up maximum up to plus 6 oxidation state. Andre maximum it can lose 6 electron. Okay, now if they ask you chromium, molybdenum, tungsten, all are in plus 6 oxidation state, they will now ask you which will be highly stable, or better than that, they would ask you which is least stable. Your answer should be chromium. Why? Remember one thing, I want everybody to note down this point as well. Higher oxidation state is stabilized by larger atoms. Okay, look, chromium, molybdenum, tungsten, these are the elements that you would see in a single group. Okay, this is 3D element, this is 4D element, this is 5D element. Okay, now when you move down the group, generally what will happen? The size increases. Okay, the larger size molybdenum and tungsten will be able to stabilize larger oxidation state, while chromium, having a small size compared to these two, will not be able to have a stable oxidation state plus 6. Okay, not so stable compared to this. This is relative, I'm telling relatively. Okay, compared to this will not be more stable. Remember this point as well. Now, look, I told you potassium, sodium, all this will show a single oxidation state, +1. And these transition elements, they will show multiple oxidation state. Why so? Why do they show this kind of multiple oxidation state? You need to know the reason behind that as well. Now, if I take for example iron, argon 18, 3d6, 4s2. Okay, if I have to convert this into iron 2 plus, I would remove these two electrons. If I have to convert this into iron 3 plus, I will remove these two electrons. Along with that, I am also going to remove electron from the 3d. Alva? So that means in transition metal ions, we can remove electron from 4s orbital, as well as from 3d orbital. Why so? Why are we able to remove electron from 4s as well as 3d orbital? Because the difference in energy is small. And you have 4s energy level over here. 3d energy level is very close to this 4s. Okay. If you are able to remove electron from 4s, it is quite obvious you will also be able to remove electron from 3d. There is no large energy gap between these two. That's why you are able to remove electron from both the energy level. So in that case, they can show multiple oxidation state. Okay, remember this as well. Why? The reason behind this. Actually, in inorganic chemistry, it is quite difficult to find out the reason compared to organic chemistry. Wherever you get a reason, remember those reasons. Okay, now based on these concepts, we shall try to answer some question. Yes. Those who have cue cards, you can answer using cue card. I
Option
think
C.
Nippani students have St. Joseph. Option?
Option C.
Option C.
C.
Option
C.
C.
Option C. Option
Option
C.
C.
Option C.
C. C.
Option C.
Which of the following elements forms the highest valent oxide?
Option C, ma'am.
What do you mean by highest? Yes, option C. I'm just waiting for this cue card result.
Miss,
Then let me ask you one question. Yes?
what you what is the meaning of valent oxide?
Ah, that's what I was about to ask because everybody answered option C. Let us ask those who have answered as option C. Now, what do you mean by this highest valent oxide? Does anybody know this? Highest valent oxide. You're answering option C. Are you taking this in terms of maximum oxidation state? Am I correct? Yes or no? How do you say manganese will be having a highest valent oxide? You have answer. Your answer is correct also, but you people have no idea how that is a correct answer. Nobody? Anybody from Nippani? Anybody from Raibag? Can you explain me? You're pretty quick in answering, but you don't know what is valent oxide. Without knowing question only you are trying to answer. Huh? So highest valent oxide means yes. In a way we can say that it is going to show the maximum oxidation state, which is going to show maximum oxidation state. Now, Andre, it will use up all of its valence electron to form a bond. Now, if I'm saying manganese will exist as Mn2O7, this is the oxide of manganese where I can see maximum oxidation state of manganese. That means manganese has used all its valence electron. How many valence electrons are there for manganese? How many do you take? Manganese
7.
valence electron. 7 alva. So if you find out the oxidation state of manganese in this, 2x plus 7 into minus 2 for oxygen equal to 0. 2x minus 14 equal to 0, x will be equal to plus 7. Okay, manganese has an oxide like this, in which manganese show plus 7 oxide, plus 7 oxidation state. Plus 7 oxidation state means it has utilized all the 7 valence electron. Okay, that is what valent oxide mean. Your answer is correct. Option C, manganese. Now, okay, let me see who will answer this. Which of the following has largest radii? Just apply the common, ionic radii, this thing, concept. I mean, you don't have to study D and F block elements to answer this. Ionic radii, how does it vary across the period and down the group? Just apply that concept, you'll be able to answer this question. Across the period, what happens to ionic radii? Yesterday we were discussing this,
Decreases.
right? Faz's rule.
Decrease.
Down the group,
Increase.
Now we have all the 4 ions which are in the same period, but you have to know the order, how they are arranged. By the way, we don't have this D block elements over here. This is general trend for S and P.
Option A,
Definitely
ma'am.
have not
Option
got
A.
the D block
Option
elements.
A.
Option A. Very good. Very good. Yes. Yes. Poll result is also saying option A. Chromium, manganese, iron, cobalt. Okay. Along the period, ionic radius decreases. So this will have a largest, this will have a smallest. Okay. Yes. Chromium is correct. Good. Okay. Now we'll discuss other properties of this transition elements. Another property of transition element is that it forms alloys. What do you mean by alloy? Alloy. Everybody should know this, I guess.
Combination of metal,
Alloy.
non-metal.
Ionization.
Metal and metal,
Yes.
non-metal.
Not metal.
Yes,
Combination.
yes, right. So generally, if you observe these alloys, major alloys, they consist of transition metals, and these alloys are generally made up of 2 to 3 transition metal itself, or the D block elements itself. Now, why do these D block elements are, they are being used for the formation of alloy? Because alloy, if you take the exact definition of alloy, it is a homogeneous mixture of 2 or more elements like metals or not metals.
Hello.
Now, the basic criteria to form an alloy is that the sizes should be small and comparable. That means the size difference between 2 or 3 elements which you are mixing to form an alloy should be less. Okay, that is happening in case of transition elements or D block metals. You take all the D block elements. Now just we discussed across the period the radii decreases. Yes, I agree, the radii decreases, all those. But the difference in radii, the difference in size between any 2 D block element you take, that is not too much. So if you have those kind of elements, that mixing those elements is quite easy, and those kind of elements will form alloy. Okay, the major reason why D block elements form alloy is because they don't have much size difference. In this chapter, you have to remember these reasons only. Why? The question will be based on that only. Okay. One more thing is they form a kind of compound called interstitial compounds. Okay, now what are interstitial compound? I take transition metal system. Here I have all the metals attracted, metal atoms, let us say this is some iron atoms, attracted towards each other by metallic bonding. When they are joined or when they are structured in this way, there are some vacant spaces. Okay, vacant spaces. These are called as interstitial sites. Interstitial sites. Now, some small atoms like hydrogen, carbon, nitrogen, they will acquire or they will get placed in these vacant spaces. They will come and sit in these vacant spaces. Now, when hydrogen, carbon or nitrogen, if these small atoms take up these vacant spaces, they will form a new compound called interstitial compounds. Okay, interstitial compounds means small atoms like these, they will take up the vacant spaces present in the transition metal atom, transition metal lattice, crystal lattice. Now, when you have interstitial compounds, these, they will generally have high melting point compared to simple transition element system, and they're more harder. Okay, the hardness of these transition elements increases. Some of the interstitial compounds are as hard as diamond. Okay, are as hard as diamonds, and they're chemically inert. Chemically inert, what do you mean by inertness? What do you mean by chemically inert?
Not
Any
react
idea?
with other elements.
Huh? Come again?
Chemically inactive, ma'am.
Low reactive.
No, yes, low reactivity. They doesn't react easily. Okay, so these 3 pointers about interstitial compound you have to remember. When you form an interstitial compound, its metallic property increases, its hardness increases, its melting point increases, and it becomes chemically inert. Okay, these two are one of the property. There is one more property you should be knowing about this property of transition element. That is,
Catalytic property.
it will, yes, it will act as a catalyst. You might have seen, I mean, I think from some ninth or 10th grade, where you, when you started studying a bit about organic chemistry, you might have seen in many reduction reaction, we use this, we use something like this: nickel over hydrogen, platinum over hydrogen, right? Now, what is this nickel platinum doing? These transition metals, they are acting as catalyst. What do you mean by catalyst?
Increase the rate
Catalyst.
of reaction.
Is the rate of reaction.
Yes. Yes. Catalyst is a substance which will increase the rate of a reaction. Which will increase the rate of a reaction. And it will increase the speed of a reaction. If a reaction takes 1 hour to complete, now if I add catalyst to that, the reaction might take some 15-20 minutes to complete. Okay, that's what catalyst does to a reaction. Now, why this transition metal show catalytic property? Two reasons you have to remember: high surface area and ability to show multiple oxidation state. Ability to show multiple oxidation state. Can you quickly note down this? After this, we'll go to question. These 2 points about transition metal being a catalyst is very, very important. Repeatedly, this question is being asked. Okay, that's why I'm making you to note down this. High surface area, ability to show multiple oxidation state. We'll discuss question later. If we get time, we'll discuss why these two will enhance the property, catalytic property. High surface area, ability to show multiple oxidation state. Done. Okay.
Option D.
Can you tell me?
Option D, ma'am.
This is
Option D.
actually quite
Option D.
Option D, miss.
Option D. Option D.
Option D.
Option D.
Option A, ma'am.
D.
Option M.
Option D, ma'am.
Option D.
Option A, ma'am.
Option A. Okay. Now,
The name is
there is one discrepancy in this question. This question is not exactly right, I would say. Why? Just now we discussed it will show catalytic property. Option D, I'm getting mm, only between option A and D. The answer is between option A and D. No one is going with option B or option C. I can see that from poll result. Now this question is quite confusing and this is not very correct, I would say. Why? Because we completely agree that it can show catalytic property. Just now we discussed. Now we have seen some transition elements having unpaired electron, they show paramagnetic behavior. But not necessary that every d block element should have unpaired electron all the time, right? If it doesn't have unpaired electron, it will show diamagnetic property also. Am I correct?
Yes.
Am I correct? Alva. Unpaired idre it will show paramagnetic. If it doesn't have unpaired electron, it will show diamagnetic. And we know already it will show catalytic property also. So actually, I think option B, it shouldn't be only both A, B. It should be A, B and C. All the three properties will be shown by transition element. We cannot omit diamagnetic property. Okay? So according to me, it should be A, B and C. Yes. D block
Option,
elements generally form.
option C.
Very easy.
C, ma'am. Option
Option
C.
C? Yes.
option
Yes.
C.
Option C.
Interstitial
Option C.
hydrides. Yes. 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 Very good. Very good. Interstitial hydrides means it should have hydrogen atom like FeH. And one more thing, you can take the example. Sometimes what will happen, let's say you have some titanium 1.5, something like this. These interstitial compounds, they are also called as non-stoichiometric compound. Okay? Remember this also. They are also called as non-stoichiometric. That means not necessary that the amount of hydrogen, carbon and nitrogen when you write the molecular formula, it will not be in a whole number. Like this also possible. Okay? You have to remember that. We'll go to next question. Yes. This one, which is not a hard metal. A hard metal.
Me, ma'am.
Option B.
Option B. Option B, ma'am.
Option B.
Second
Second,
one.
Ni-
Second
Nibbani
one.
students,
Option
you can
D.
answer using Q card. D.
Option B, second one.
The second one.
Second.
This is based on a concept that I discussed yesterday. If you remember that, you can somehow relate that concept. I'm waiting for poll result. Then let me explain. Okay. Okay.
Option second, ma'am.
Yes. Option second. Why option second? Can you tell me? You're correct. Option second is correct. Why option two? Anybody, can you explain? Something related to that. Why zinc, cadmium, mercury are D block element but not transition element? Something
Pseudo
related to that.
transition element.
Fulfilled.
Excipitant hardness decrease.
Completely filled here.
Yes, it has completely filled orbitals. So zinc, cadmium, mercury, they have completely filled orbital. That means they don't have unpaired electron. They don't have unpaired electron. No unpaired electron means very weak metallic bonding. Very weak metallic bonding. Weak metallic bonding means it is not so hard. It is soft. Okay? If the metallic bonding is strong, the metal will be very hard. If the metallic bonding is weak, the metal will be soft. Okay? So these will have very weak metallic bonding due to no unpaired electron. So that's why the answer is B. You're correct. Okay. Next. Okay. This one, transition elements have more tendency to form interstitial compounds because of
A. Option A.
Option A.
B, ma'am.
option A.
Option A, miss.
Option B, ma'am. Option B, ma'am.
Option A.
Option B.
Option A.
Option A. Option A.
Okay. Okay. Okay.
Miss,
Okay.
option A.
Option B, ma'am.
Option A,
Option
miss.
B. Huh. Okay.
Option
Option
B.
A,
Option
ma'am.
B, ma'am.
Nip,
Option A, ma'am.
yes.
Option A.
Nippani Joseph's.
Option A, miss.
This one, Q
Option A,
card.
ma'am. Option A,
Second
Done.
ma'am.
option,
Done.
ma'am.
Okay. I got your answer A and B. Okay. Yes. So A and B LA competition. Yes. Majority is going with B. If you're going with B, you are correct. Defects in their crystal lattice. The defects means the same thing, the vacancies. The vacancies, that are the defects. Okay. Due to that, we have interstitial compound. So same atomic size, similar atomic size is not for this. It is for alloy formation. Okay. It is for alloy formation. Option B is correct. Good. Yes, this one.
Option B.
Option B. Okay. Others?
Option B, ma'am. Option B.
Yes.
Option B. Option
Yes.
B,
Poll
ma'am.
result also say very good. Small difference in atomic size is reason for them acting as an alloy. Very good. Very good. Okay. So that means now you are pakka with alloy concept, interstitial compounds concept. Next class we shall discuss more about transition elements. Okay. Thank you, students. Give your attendance to the coordinator. Thank you.
Thank you,
Thank you,
ma'am.
ma'am. Bye.
Bye,
Thank you, ma'am.